You now know how to find the real and complex zeros of a polynomial and how to interpret them. Now we will see how to find the rational zeros of a polynomial. What is the meaning of a rational zero? A zero of the form b over c. Suppose you have 2x plus 1 as a factor of a polynomial. In order to find the zeros, you set that factor to 0. 2x plus 1 equal to 0 will give you x equal to negative 1/2. That's a rational number, and that is a rational zero of that polynomial. Now, let's consider the polynomial function 8x squared minus 2x minus 3. Now, if I ask you to find the zeros of this polynomial, now what will you do? Now remember, the best way to find the zeros of a polynomial is to see if you can factor the polynomial. If you can factor a polynomial, then set the factors equal to 0 and solve for x. We can find the zeros. Can you factor 8x squared minus 2x minus 3? Now, I had actually given you a method of factoring this. Now, the method I showed you is factor the first term. All right, there are many ways you can do it. 8x squared can be factored as 8x times x, 4x times 2x. Now, always try the middle kind of factoring. That is, try 8x squared as 4x times 2x. So put your line like this and write the factors of 8x squared as 4x and 2x. And then factor the last term, negative 3. Now, what are the factors of negative 3? There are only two possibilities for factoring negative 3. It is either 3 times negative 1 or negative 3 times positive 1. And remember again the method I gave you. Write those numbers here, then multiply across and add them. You must get the middle term. In other words, when you write the factors of negative 3 in these two positions, then multiply along the line. That's the line is meant for. And add, you must get negative 2. So how do we write it? What are the factors? You need to do it by trial and error. I'm going to say negative 3 times positive 1. So negative 3 is factored as negative 3 times positive 1. Now let's multiply. Negative 3 times 2 is negative 6x. Positive 1 times 4x is 4x. 4x added to negative 6x is negative 2x. Yes. If you do not get, when you multiply across and do not get the middle term, that means your orientations are not right. But now that the orientations are right, how do we pick our factors? The first factor is 4x minus 3. And the second factor is 2x plus 1. And therefore, we say 8x squared minus 2x minus 3 is 4x minus 3 times 2x plus 1. All right? In order to find the zeros of a polynomial, we set the polynomial to 0. In other words, we set each of the factors to 0. All right, let's start with the first factor. 4x minus 3 equal to 0 gives, tell me, what is the value of x here? X equal to 3 over 4. That's right. This is a rational zero. And you can also set the next factor. 2x plus 1 equal to 0 gives x equal to negative 1/2. I hope you can do that on your own. So you found two zeros, x equal to 3/4 and x equal to negative 1/2. Now go back and look at our theorem once again. If x equal to 3 over 4 is a 0, then x minus 3 over 4 is a factor. Now x minus 3 over 4 is the same as 4x minus 3. I'm going to leave it for you to think about it. Okay, so x equal to 3 over 4 and x equal to negative 1/2 are the rational zeros of P of x. Rational zeros are of the form a over b or b over c. It's got a numerator and a denominator. Now, I want you to watch this. The numerators of the zeros are 3 and negative 1. I want you to understand this x equal to negative 1/2 as negative 1 divided by 2. That's the best way to understand it. That means the numerator of the first 0 is 3 and the numerator of the second 0 is negative 1. Now look at that. These are the numbers, negative 3 and positive 1. So the numerators 3 and negative 1 are the factors of the last term, negative 3 and positive 1. And how about the denominators? The denominator of the first factor is 4, denominator of the second factor is 2, and they are actually the factors of the constant term of the first term, 8x squared. 8 is 4 times 2. The denominators 4 and 2 of these zeros are factors of the leading coefficient 8 of P of x. So when you write and factor like this, all these things become clear. So we can use this to make a general statement about rational zeros. Now what is a general statement going to be? For the rational zeros, the numerator of the rational zeros will be the factors of the constant term, and the denominators will be the factors of the leading coefficient. That's right. So if b over c is a rational zero of a polynomial, then b must be an integer factor of the constant term. That's right. That b, the numerator, has to be an integer factor of the constant term, and the c has to be an integer factor of the leading coefficient. The denominator must be an integer factor of the leading coefficient. That's an important theorem in finding the rational zeros of a polynomial. Alright, let's do a problem. Find all rational zeros of P of x equal to 2x cubed minus 9x squared plus 14x minus 5. Well, the factors of negative 5 are 5 and negative 1. Is that right? The constant term is negative 5. That means the factors of negative 5 can be negative 5 and 1 or 5 and negative 1. Now that means the numerator of the rational zero must be an integer factor of that constant term. That means the numerator of the rational zeros can be negative 5, it can be 1, it can be 5 or negative 1. And the factors of the leading term, or in other words, plus or minus 5 or plus or minus 1 are the possible values of b. What does b stands for? We are looking for the rational zero of the form b over c. b is the numerator, and that numerator has to be an integer factor of the constant term. So plus or minus 5, plus or minus 1 are the possible values of b. And the factors of the leading coefficient 2, what are the possible factors? Can be 2 and 1 or negative 2 or negative 1. That means plus or minus 2 or plus or minus 1 are possible values of c. So you can have 4 possible numerators and 4 possible denominators. So what are the possible zeros? So the possible rational zeros are of the form b over c, and what are they? It can be plus or minus 1, plus or minus 5, plus or minus 5 over 2, and plus or minus 1/2. You see, we said plus or minus 5 or plus or minus 1 has to be the numerator, and all these are taken care of here. So when plus or minus 1 is the numerator and plus or minus 1 are the denominator, you can have this. Is that right? And plus or minus 5 is the numerator and plus or minus 1 are the denominator, then these are the zeros. So these are the possible rational zeros of the polynomial. Now remember, a rational zero is the same as also a real zero. You see, 5 is a rational number because 5 is 5 over 1. Now we will use TI-84 to figure out which of these represent the rational zeros of P of x. So we now know that these are the possible zeros. And so we will now use the TI-84 and use the common method. What's the common method again? Press application and the down arrow until you reach the polysymult. Then enter a couple of times and enter the degree of the polynomial and enter. And on the next screen, enter your A3 equal to 2, A2 equal to -9, A1 equal to 14, A0 equal to -5, and solve. This is what you get. The calculator gives you x1 equal to 0.5, which means, look at this, we said plus or minus 1/2 are 2 possible zeros. Now the calculator said, yes, 0.5 is a 0. That means 1/2 is a rational zero. Alright, so x equal to 1/2 is a rational zero of P of x. And now, once you know 1 0, we can now figure out, we know 1 factor, is that right? And then we can obtain the remaining factors by using synthetic division. You see, we have that skill and we're going to use that all along. To obtain the complex zeros, we do synthetic division on the polynomial using the 0 x equal to 1/2 and obtain the remaining factor. Alright, let's do that. Do we have to do that? Yes. Now here we got the coefficients 2, -9, 14, -5. And we got the horizontal line, we got the vertical line, and we know that x equal to 1/2 is the 0. And so what is the number we're going to put here? 1/2. Alright, now let's do the normal procedure. Bring down the 2, multiply 2 by 1/2. 2 times 1/2 is 1. Write it below -9. -9 plus 1 is -8. -8 times 1/2 is -4. Write it below 14. 14 added to -4 is 10. 10 times -1, 10 times 1/2 is 5. Right below 5. And add them, you get 0. Well, that means remainder is 0, means x equal to 1/2 is a 0. X minus 1/2 is the factor. And what is the remaining factor? Since the degree of the polynomial is 3, the remaining factor must be of degree 2. So that will be 2x squared. 2x squared minus 8x plus 10 is the remaining factor. Alright, is it possible to factor it? Now, so to find the complex zeros, we will solve this equation using the quadratic formula. Since you cannot factor it, you know it's not going to be real zeros. So we've got to use the quadratic formula. Again, we did that in the last lesson, in the first part of this lesson. ax squared plus bx plus c equal to 0, our a equal to 2, b equal to -8, and c equal to 10. And what is the quadratic formula we have? X equal to -b plus or minus square root b squared minus 4ac over 2a. Now remember, only by doing this you will actually learn. So don't just watch me, you've got to keep doing it. Alright, replace all the values. That will be -b, negative of -8, plus or minus square root b squared is -8 squared, that is 64, minus 4a is 2, times c is 10, all over 2a, 2 times 2. Okay, simplify this. That will be -8 is +8, plus or minus 64 minus 4 times 2 is 8 times 10 is 80. 64 minus 80 divided by 4. And let's go over there now. That will be -8 plus or minus square root 64 minus 80 is -16 divided by 4. Alright, you need to now tell me, what is square root -16? That will be square root of -1 times square root of 16, and square root -1 is your I, so that will be 4i. So that will be 8 plus or minus 4i divided by 4. And on the numerator you can factor out a 4. Is that right? That will be 4 times 2 plus I over 4. The 4 and 4 conveniently cancel. So the results are x equal to 2 plus or minus I. 2 plus I is a complex zero. 2 minus I is a complex zero. Alright. So what are the zeros we have now? We have a rational zero, x equal to 1/2. We have a complex zero, x equal to 2 plus I. Well, and another complex zero, 2 minus I. Now remember, if x equal to 2 plus I is a 0, then x minus 2 plus I is a factor of p of x. Is that right? Yes, because if x equal to r is a factor, then x minus r, if x equal to r is a 0 of the polynomial, then x minus r is a factor of the polynomial. Similarly, if x equal to 2 plus I, you must think of it as a quantity. X equal to 2 plus I is a 0, then x minus the quantity 2 plus I will be a factor of that polynomial. Similarly, if x equal to 2 minus I is a 0, then what is a factor? Then x minus 2 minus I is a factor. Alright? That means if you multiply 2 plus I, if you multiply these two factors, this is a factor of this polynomial. Remember, the zeros 2 plus I and 2 minus I are for this part of the polynomial. And that means this can be factored as x minus quantity 2 plus I times x minus quantity 2 minus I. So this can now be written as x minus 2 plus I times x minus 2 minus I. Right. Now, I'm going to give you a challenge. Can you multiply x minus 2 plus I times x minus 2 minus I and show that it is equal to 2x squared minus 8x plus 10. There will be a big challenge there. The challenge is that you may not get this exact quantity. If you notice, 2x squared minus 8x plus 10 has a common factor. What is the common factor there? It's that 2. If you take that 2 out, it will be 2 times x squared minus 4x plus 5. Now when you multiply these two factors, what it will give you is only x squared minus 4x plus 5 and not the whole of it. It will not give you that 2. Well, you must tell me why it is so. Alright, do this and let me know if you want to earn some extra credits. Okay, another one. Write p of x equal to 3x cubed minus 10x squared plus 31x plus 26 as the product of two factors, given that x equal to negative 2/3 is a 0. What is the conclusion? If x equal to negative 2/3 is a 0, it means x plus 2/3 is a factor. That means you have been asked to write it as the product of two factors. One factor we already have, x plus 2/3. Now how do we get the other part, the other remaining factor? Well, by doing a synthetic division using the 0, isn't it? Okay, so x plus 2/3 is a linear factor. Therefore, we use synthetic division to find the other remaining linear factor. Let's pick the coefficients. It will be 3, negative 10, all the powers, all the terms are there. 3, negative 10, 31, 26. Alright, we have the horizontal line, the vertical line. What is the number that we're going to use here? The number is the 0, that is negative 2/3. So that's negative 2/3 there. And now bring down the 3. Okay, now keep your mind active. Negative 2/3 times 3. What is negative 2/3 times 3? The 3's will cancel. That will be negative 2. We'll write it below negative 10. Add the 2. Negative 10 added to negative 2 is negative 12. Alright, now, again keep your mind alive. Negative 2/3 multiplied by negative 12. First of all, the negatives will make positive. 3 goes in 12 4 times. 4 times 2 is 8. That's right. Okay. Now, 31 plus 8 is 39. Now multiply 39 by negative 2/3. Well, this is negative, that's positive, so the result will be negative. And when you multiply negative 2/3 with 39, 3 goes in 39. 3 times 13 is 39. So that will be 13 times 2 is 26. So that will be negative 26. And add, you get 0. And therefore, what is the remaining factor? Since our original polynomial is a third-degree polynomial, the remaining factor will be a quadratic factor. That will be 3x squared minus 12x plus 39. And that is the remaining factor. And therefore, how do you write this polynomial as the product of two factors? It will be x plus 2/3 times 3x squared minus 12x plus 39. But you see, writing a polynomial like this is a very awkward thing. We need to simplify it and write it in a more civilized way. How? In this factor, take 3 as the common denominator and simplify. What does that give you? It will be 3 on the denominator and 3x plus 2 on the numerator. And that will be 3x plus 2 over 3 times 3x squared minus 12x plus 39. And if you take this 3 and put it in the denominator here, does it make any difference? You see, a over b times c is the same as a times c over b. Makes no difference. So write it like this. It'll be 3x plus 2 times 3x squared minus 12x plus 39 over 3. What's the advantage? The advantage is there is a 3 common in the numerator there. When you factor that 3 out, the remaining will be x squared minus 4x plus 13. And the 3 will cancel. Or you can do it like this. Split this into 3 terms. It'll be 3x plus 2 times 3x squared over 3 minus 12x over 3 plus 39 over 3. And that gives you 3x squared over 3 is x squared minus 12x over 3 is 4x plus 39 over 3 is 13. So our polynomial written as the product of two factors is 3x plus 2 times x squared minus 4x plus 13. Alright. Another one. Find the roots of the equation. What is the meaning of roots of the equation? We have an equation x to the power of 4 minus 2x squared minus 16x minus 15 equal to 0. That's the equation. What's the meaning of roots of an equation? Roots of the equation are the values of x that makes the equation true. In other words, simply, roots of the equation are the solutions of that equation. The roots of the equation are the values of x that make the equation true. They are the zeros of the corresponding polynomial, another way of asking the same thing. Now, we start by finding the real zeros of this on TI-84. Alright? Find the real zeros of this on TI-84 on your own. Press application. Go down to find polynomial. Enter a couple of times. And the degree of the polynomial is 4. Enter. And then look at the coefficients. Be careful here. X to the power of 4. And the next one is x squared. Means x cubed term is 0. So you must use that. A4 is 1. A3 is 0. A2 is negative 2. A1 is negative 16. A0 is negative 15. And solve. You get x1 equal to negative 1. x2 equal to 3 are the real zeros. In other words, we've got two factors of this already. There are only two more factors remaining which we need to find. If x equal to negative 1 is a zero of the polynomial, x plus 1 is a factor of it. X equal to 3 is a 0. It means x minus 3 is a factor of it. Well, what we need to do is we must do a synthetic division on this first by using the first 0, obtain the remaining factor, and then do a synthetic division on the remaining factor using the 0 x equal to 3, and that will give you the remaining factor. You understand that? And then we will look for the complex zeros. Alright, so x equal to negative 1 is a real 0, and we will do a synthetic division on this using this 0. Alright, let's put the coefficients. What are the coefficients? It will be 1, 0, is that right? 1, 0, negative 2, negative 16, negative 15. Your horizontal line and vertical line. And x equal to negative 1 is the 0, so that negative 1 there. Bring down the 1. Multiply. 1 times negative 1 is negative 1. Add negative 1. Negative 1 times negative 1 is positive 1. Negative 2 added to positive 1 is negative 1. Negative 1 times negative 1 is positive 1. Added gives me negative 15. Negative 1 times negative 15 is positive 15. And the sum is 0. Well, obviously, we know x equal to negative 1 is a 0. And therefore, what is the remaining polynomial? We don't even need to write the remaining polynomial. These are the coefficients of the remaining polynomial. We can now do a synthetic division on this using the second 0. So, although we don't need to, but we can, it will be x cubed minus x squared minus x minus 15 is the remaining factor. Now, x equal to 3 is a real 0, so we do a synthetic division on this using that 0. Alright, let's do that. That'll be 1, negative 1, negative 1, negative 15. Those are the zeros here. And now horizontal line, vertical line, x equal to 3 is a 0. There we go. Alright, bring down the 1. 1 times 3 is 3. 3 plus negative 1 is 2. 2 times 3 is 6. That will be 5. 5 times 3 is 15. And that is 0. Well, when x equal to 3 is a 0, we get the remaining factor is, what's the remaining factor? You must be able to read it quickly now. It will be x squared plus 2x plus 5 is the remaining factor. There you are. So, using the two given real zeros by doing the synthetic division, we have now arrived at the remaining factor. That means this x to the power of 4 minus 2x squared minus 16x minus 15 can now be written as x plus 1, that's a factor, times x minus 3 times x squared plus 2x plus 5. That's what it means. Now, I don't think we can factor it, can we? No. That means we need to find the complex zeros of this by using the quadratic equation. That's right. Now, solve x squared plus 2x plus 5 equal to 0 by the quadratic formula. Now, pick your a, b, and c. A equal to 1, b equal to 2, and c equal to 5. And use it in the quadratic formula. Well, negative b, that is negative 2, plus or minus square root b squared is 4, minus 4 times a times c, 4 times 1 times 5, over 2 times 1. And simplify that. That will be negative 2 plus or minus square root 4 minus 20 over 2. And that equal to square root 4 minus 20 square root negative 16. And you know from many of our problems before, square root negative 16 is 4i. That's right. So that will be negative 2 plus or minus 4i divided by 2. As we did in the previous cases several times, there is a 2 that is common on the numerator, so factor that out. That will be 2 times negative 1 plus or minus 2i all over 2. And the 2's will cancel. That means the complex zeros of this polynomial are negative 1 plus or minus 2i. So what are the roots of the equation? The roots of the equation are x equal to negative 1, x equal to 3, x equal to negative 1 plus 2i, x equal to negative 1 minus 2i. Those are the zeros, or those are the roots of the polynomial. X equal to negative 1, x equal to 3, x equal to negative 1 plus 2i, and x equal to negative 1 minus 2i. In fact, the zeros of a polynomial is the same as the roots of the polynomial when it is set equal to 0. Polynomial equation. Okay, another one. Find all zeros of x to the power 4 minus 13 over 4x squared minus 5 over 2x minus 1/4. Now remember, I told you earlier, multiplying a polynomial by a constant number will not change the zeros of the polynomial. So if you want to write this polynomial, clean it up and write it more neatly, we can multiply this with a constant number. Multiplying by a constant number will not change the zeros of the polynomial. So multiply this polynomial each term by 4. Multiply every term by 4. Now remember, multiplying a polynomial by a number will change the value of the polynomial. Now since we are not looking for the value of the polynomial, we are only looking for the zeros. The zeros of a polynomial will not change by multiplying by a constant. For example, if a polynomial is x plus 2, what is the zero of that? X equal to negative 2. If you multiply x plus 2 by 5, will it change the zero of the polynomial? 5 times x plus 2 equal to 0. 5 is not equal to 0. X plus 2 equal to 0. The 0 is still x equal to negative 2. Alright, multiply every term by 4. That gives you 4x to the power 4 minus 13x squared minus 10x minus 1. And this polynomial can be written as 4x to the 4 minus 13x squared minus 10x minus 1. Now I want to emphasize once again, the value of this polynomial is not the same as this polynomial, but the zeros of these two polynomials are the same, because we obtained this by simply multiplying the first polynomial by a constant number 4. We start by finding the real zeros on TI-84, and I'm going to leave it for you to do it on your own. Now look at this and tell me what are the real zeros. If you look at this, this is a rational zero, that is a rational zero. You can read this one as negative 1, is that right? This is a negative 1, that's a negative 1. That means negative 1 occurs twice. X equal to negative 1 is an integer zero of multiplicity 2. So you got an integer zero twice. That means the other two are rational zeros. Well, so what we do is we do a synthetic division twice using x equal to negative 1. Why do we do it twice? Because x plus 1 times x plus 1 are both factors of the polynomial. Alright, let's take the constant coefficients. 4, there is no x cubed term, so 4, 0, negative 13, negative 10, minus 1. And x equal to negative 1 is the 0 we're going to use for the synthetic division. Alright, that'll be 4, carried down. 4 times negative 1 is negative 4. Added to 0 is negative 4. Negative 4 times negative 1 is positive 5. Positive 4. Negative 13 plus 4 is negative 9. Negative 9 times negative 1 is positive 9. Right here. 9 added to negative 10 is negative 1. Negative 1 times negative 1 is positive 1. And the remainder 0. And we need to do another synthetic division on these coefficients by negative 1. Well, the remaining factor is 4x cubed minus 4x squared minus 9x minus 1. And we repeat the synthetic division on these coefficients. Alright, again negative 1, bring down the 4. 4 times negative 1 is negative 4. Negative 4 added to negative 4 is negative 8. Negative 8 times negative 1 is positive 8. Positive 8 added to negative 9 is negative 1. Negative 1 times negative 1 is positive 1. That gives you 0. Alright. We have now, we use two synthetic divisions. X plus 1 is a factor. X equal to negative 1 is a 0. Again, x plus 1 is a factor. That means x equal to negative 1 is a 0. And the remaining factor, therefore, is, what is the remaining factor? 4x squared minus 8x minus 1 is the remaining factor. 4x squared minus 8x minus 1 is the remaining factor. And this cannot be factored. We have to do the simplification on quadratic equation. Alright, to find the rational zeros, we solve 4x squared minus 8x minus 1 equal to 0 by using the quadratic equation. A equal to 4, B equal to negative 8, C equal to negative 1. And use these values there. Negative B, negative times negative 8, plus or minus square root b squared negative 8 all squared is 64 minus 4a, a is 4, times c is negative 1 over 2 times a is 2 times 4. And that gives you 8 plus or minus square root 64 plus 16 over 8. Well, and that is 8 plus or minus square root 80 over 8. Can you simplify that? That will be 8 plus or minus square root 80 can be written as 16 times 5. Why did I write 16 times 5 and not 20 times 4 or 40 times 2? Because 16 is a perfect square and the square root can be obtained. So, how does this become now? This will be square root 16 times square root 5. Square root 16 is 4, so this will become 4 square root 5. So that will be 8 plus or minus 4 square root 5 over 8. And now I can factor out a 4 from the numerator. That will be 4 times 2 plus or minus square root 5 over 8. And the 4 cancels with the 8, leaving a 2 there. So that will be 2 plus or minus square root 5 divided by 2. Now this gives you 2 rational zeros. That is 2 plus square root 5 over 2 and 2 minus square root 5 over 2. So one rational zero is 2 minus square root 5 over 2. And that is approximately negative 0.118. This is the exact rational zero. This is the approximate value. The second is x equal to 2 plus square root 5 over 2. And the approximate value of that is 2.118. Now, look at what the calculator gave you earlier. We had these two are the integer zeros. And those two are the rational zeros. Look at that, the first one, negative 0.118. That's what we just produced. And the second one, 2.118. And that's what this is. So the calculator actually gives it to you, but not in the form we want. We need to express it in the form b over c. So we need to go back and do this kind of work. Now look at the graph of that function, where its zeros are represented. You have a 1, 2, 3. It crosses the x-axis at 3 places. Another one. Write the polynomial p of x equal to x cubed minus 8x squared plus 17x minus 4 as the product of linear factors. In other words, we need to obtain the zeros and produce the linear factors. Maybe integer factors and rational factors, and then we will multiply all the factors and obtain the results that we want. Start by finding the real integer zeros. Alright, first we go to the calculator, and if you notice, the calculator gave you 3 zeros. Well, of course, they're cubic function. And out of the 3 zeros, 2 are rational. But the third also is rational. But the third one is an integer. It's a rational integer. So we find the real integer zeros, which is x equal to 4, which means x minus 4 is a factor of this. So x equal to 4 is a real integer 0, means x minus 4 is a linear factor. Once you have the integer factor, we can do a synthetic division and find the remaining factor. Alright, let's do that. Pick the coefficients a3, a2, a1, a0 are these numbers. And we divide it by the 0, which is x equal to 4. Bring down the 1. 1 times 4 is 4. Negative 8 plus 4 is negative 4. We have been doing this for so long, I'm sure this is now very familiar to you. What's the next step? Negative 4 times 4 is negative 16 over here. Add them together, there is 1. 1 times 4 is 4. Adding in gives you 0. So 4 is a 0 of the polynomial. X minus 4 is a linear factor. Therefore, the remaining factor is, can you read it? It will be x squared minus 4x plus 1 is the remaining factor. And to find the rational factors of these, we can use the quadratic equation, quadratic formula. Now this has 2 irrational zeros, and we use the quadratic formula to find them. That is a equal to 1, b equal to negative 4, and c equal to 1. And use the formula and replace your a, b, and c. b equal to negative 4. Negative b is negative negative 4 plus or minus square root b squared, negative 4 squared is 16, minus 4ac divided by 2a. And what does that give you? That will be 4 plus or minus square root 16 minus 4 over 2. And that will be 4 plus or minus square root 12 over 2. And that will be 4 plus or minus 12 is 4 times 3. Now this will become square root 4 times square root 3, which is 2 square root 3. So look at, now you need to factor out a 2 from the numerator. That will give you 2 times 2 plus or minus square root 3 over 2. And that is 2 and 2 goes 2 plus or minus square root 3. These are 2 irrational zeros. Why are they irrational? Square root 3 is not a rational number. It's an irrational number. So 2 plus square root 3 is an irrational 0. And 2 minus square root 3 is also an irrational 0. Now tell me, if 2 plus square root 3 is an irrational 0, what is the corresponding factor of the polynomial? Well, go back to the factor theorem. If x equal to r is a 0 of the polynomial, x minus r is a factor of that polynomial. If 2 plus square root 3 is a zero of the polynomial, then x minus the quantity 2 plus 3 is a factor of the polynomial. All right, let's write that. X equal to 2 plus square root 3 is an irrational zero of the polynomial. And the corresponding factor is x minus the quantity 2 plus square root 3. Similarly, and this can be written by expanding, that is x minus 2 minus square root 3. So one factor using the irrational zero is x minus 2 minus square root 3. That is, we obtained using the zero x equal to 2 plus square root 3. Similarly, x equal to 2 minus square root 3 is an irrational zero. What is the corresponding factor of the polynomial? It will be x minus the quantity 2 minus square root 3, and distribute that negative sign, it will be x minus 2 plus square root 3. And therefore, the whole polynomial can be written as the product of three factors, as the first factor is x minus 4, x minus 4 times x minus 2 minus square root 3, that one, times x minus 2 plus square root 3. Alright, another one. The polynomial p of x equal to x to the power of 4 minus 4x cubed plus 3x squared plus 8x minus 10 has a zero x equal to 2 plus I. Find all other zeros. Now remember, if the polynomial has a zero 2 plus I, then 2 minus I also is a zero, because the complex zeros always come in pairs. The complex conjugate of 2 plus I is 2 minus I. So that must be understood. X equal to 2 plus I is a zero means that x equal to 2 minus I is also a zero. Alright. Let's do a synthetic division of the polynomial coefficients by this zero. Alright, so that will be 1, negative 4, 3, 8, negative 10. And the zero we are going to use is 2 plus I. Alright, bring down the 1. 1 multiplied by 2 plus I will be 2 plus I. Now add the 2. Negative 4 added to 2 plus I will be negative 2 plus I. Can you multiply these for me? Read it like this if you want. I plus 2 times I minus 2. See, we have been using this form many times. I plus 2 times I minus 2. What is I plus 2 times I minus 2? Will be I squared minus 2 squared. What is I squared? I squared is negative 1. That will be negative 1 minus 4. So 2 plus I times negative 2 plus I. Again, think about it like this. It will be I minus 2 times I plus 2. Will be I squared minus 2 squared, which is negative 1 minus 4 is negative 5. That's right. Add them together. That'll give you negative 2. Now this is simple. Multiply negative 2 with 2 plus I. It will be negative 4 minus 2I. There you are. And adding gives you 4 minus 2I. Alright, I'm going to leave it for you to do this multiplication. 4 minus 2I times 2 plus I. Actually, there is a simple way to do that. The simple way is 4 minus 2I, you can factor out at 2. It will be 2 times 2 minus I. Is that right? 2 times 2 minus I. And 2 minus I times 2 plus I. Tell me, what is 2 minus I times 2 plus I? Did you actually follow this? Write this 4 minus 2I, factor out of 2. It will be 2 times 2 minus I. And that 2 minus I times 2 plus I is 2 squared minus I squared. 2 squared is 4, minus I squared is minus -1. That will be plus 1. 4 plus 1, 5. So 2 plus I times 2 minus I is 5. And there is a 2 outside, we took it out. Multiply that, that would be 10. Alright, so multiplying these two should give you 10. And adding will give you 0. And therefore, this is the remaining factor. So, the synthetic division results in what? The remaining factor has this coefficient. 1, -2 plus I, -2, 4 minus 2I are the coefficients of the remaining factor. And we now do a synthetic division on it by the other 0. First we did by 2 plus I, but 2 minus I is also a 0. So, after dividing by 2 plus I, we found this is the remaining factor, or these are the coefficients of the remaining factor. So we take those coefficients and do a synthetic division by the next 0, which is 2 minus I. So that's 2 minus I. Concentrate here and see whether you actually follow this. Bring down 1, multiply by 1. 2 minus I times 1 is 2 minus I. Add, what do you get? 0. -2, positive 2 go, positive I, negative I goes. Now 0 times 2 minus I is 0. And 2 plus 0 is, 2 plus 0 is 2, not -2. Isn't it? Alright. Alright, I located the mistake. Did you locate the mistake in here? This -2 is correct. What is wrong here is, when I wrote the coefficients, these are the remaining coefficients. I rewrote it here. You can see what is the mistake I made. That is 1, that is -2 plus I, that is -2, and I only wrote 2 there. So this is actually a -2. Alright, so put that -2 there. -2 added to 0 is -2. Alright, let's now multiply this -2 with this 2 minus I. That'll be -4 plus 2I. Is that right? -2 times 2 is -4. -2 times -I is plus 2I. And 4 minus 2I added to -4 plus 2I will give you 0. That means 2 plus I is a 0. 2 minus I is a 0. And after doing the synthetic division, we found the remaining factor is this, the coefficients. This is, what's the power of this? You can see we started with x to the power of 4. That means the remaining factor here will have x to the power of 3. Therefore, this will be x to the power of 2. So this will be x squared minus 2x. That's right. The remaining factor is x squared minus 2, not minus 2x. And so, what are the factors now? We've got x equal to 2 plus I is a 0. X equal to 2 minus I is a 0. And using those, we found that the remaining factor is x squared minus 2. And we can now use this to find the rational or irrational zeros. X squared minus 2 equal to 0 gives x equal to plus or minus square root 2. That's an irrational number. That means the irrational zeros are x equal to plus square root 2 or x equal to negative square root 2. That means x minus square root 2 is a factor, x plus square root 2 is a factor. Now look at the graph of that polynomial function. You got two complex zeros and two real zeros. These are irrational but real. This is negative square root 2. This is positive square root 2. Okay. Negative square root 2, 0, and positive square root 2, 0. All right. Try another one. Find all zeros of p of x equal to 6x to the power 4 plus 35x cubed plus 2x squared minus 233x minus 360. Big numbers. We first check for real integer zeros on TI-84, and I found negative 4.5, 2.6666. So there are no real integer zeros. But we can actually deal with this. Negative 4.5 is 9 over 2. That's irrational zeros. So there are two rational zeros. Can you figure out what they are? And there are two complex zeros as well. Two rational zeros and two complex zeros. Now, using the values from TI-83, I can say x equal to negative 9 over 2 is one rational zero, and x equal to 8 over 3. Doesn't it look 2.666666 so on? It's actually 8 over 3. So, you now know the two rational zeros. Therefore, we will now do synthetic division first with negative 9 over 2, and then we obtain the remaining factor, and then do a synthetic division on that using x equal to 8 over 3 to get the still remaining factor, and then we figure out the complex zeros. Alright, let's start with the synthetic division on this. X to the power of 4, x cubed, x squared, x constant term. Always check that. And these are the coefficients. And you have negative 9 over 2. Keep a calculator with you when you do this. Bring down the 6. Now what is negative 9 over 2 times 6? You see, you can do it like this. 2 goes in 6 3 times. 3 times negative 9 is negative 27. Alright? And you get 8. Multiply negative 9 over 2 by 8. Again, 2 goes in 8 4 times. 4 times negative 9 is negative 36. Okay? And you get negative 34. Now, negative 34 multiplied by negative 9 over 2. First of all, negative and negative become positive. 2 goes in 34 17 times, and 17 times 9 is 153. And you get negative 80. Alright? Now, multiply negative 80 by negative 9 over 2. Again, negative, negative become positive. 2 goes in 80 40 times. 40 times 9 is 360. And adding gives you 0. So, the zero of the polynomial, the rational zero, negative 9 over 2, gave us this remaining factor. So the remaining factor is 6x cubed plus 8x squared minus 34x minus 80. And we can now do still another synthetic division on this using the next rational zero. Alright, let's do that. The coefficients are 6, 8, negative 34, negative 80. And the zero we're going to use is 8/3. Okay, bring down the 6. Multiply 6 times 8 third. You can tell me quickly. 3 goes in 6 2 times. 2 times 8 is 16. There you go. 8 plus 16 is 24. And multiply 24 with 8 third. 3 goes in 24 8 times. 8 times 8 is 64. Adding gives you 30. Multiply 30 times 8 third. 3 goes in 30 10 times. 10 times 8 is 80. Now we 0. That means the remaining factor is 6x squared plus 24x plus 30. That's right. And now we need to find the complex zeros of that part. Alright? We solve 6x squared plus 24x plus 30 equal to 0 for complex zeros. Now, to make it easy, first we factor out a 6. And this will be 6 times x squared plus 4x plus 5. And we don't need to worry about 6. We need only find the zeros of that part. Remember, when a polynomial is multiplied by a constant number, its zeros will not change. Or divide by a constant number, its zeros will not change. So this is now our remaining factor. So we say x squared plus 4x plus 5 equal to 0, where you have your a equal to 1, b equal to 4, and c equal to 5. And use the quadratic formula. Negative b is negative 4 plus or minus square root b squared is 16 minus 4ac is 20 over 2a. And we have done these kind of things before. Square root 16 minus 20 is square root negative 4. And square root negative 4 is square root 4 times square root negative 1, which is 2i. So this will be negative 4 plus or minus 2i all over 2. And factor out a 2 on the numerator and cancel the 2. You get the complex zeros are negative 2 plus or minus i. Negative 2 plus I is a 0. Negative 2 minus I is a 0. Therefore, the 4 zeros are negative 9 over 2, 8 over 3, 2 plus I, and 2 minus I. And these are the 4 zeros of this polynomial function. And now look at the graph of this polynomial function. There are 2 real or rational zeros and 2 complex zeros, and the real zeros means the graph will cut the x-axis. X equal to negative 9 over 2, negative 4.5 is one x-intercept. X equal to 8/3 is the other x-intercept. Well, I think I'm going to close here this lesson on zeros, which is the real zeros, the complex zeros, and rational zeros are very important, and you need to do a number of homework and get a lot more practice on it. All right?